Welcome to the video for 10-6. We're talking about circles and arcs today. We're looking at circumference and then both measure and arc length of circles, or of arcs, I should say. So we're going to get a bunch of vocab at the beginning, and then we'll talk a little bit about arcs, and then how they have measure and how they have length, and how those things are not the same thing. All right, so as we go through here, you can feel free to pause and look at anything again. I'm just going to quickly explain all the vocab words you see here. Circles are just a set of points equidistant from some center. So every circle has a center. You name a circle by the center. So up here is where it says, you could write this and read it out loud, circle P. A diameter is going to be all the way through the center. It's going to be a line that contains the center and both endpoints, so it's going all the way across directly through the center. All right, radius is half of that, so a radius would just go from one point on the circle to the center. Congruent circles have congruent radii, so if two different circles have the same radius, that means that they have the same area. And a central angle, we've talked about this one a bunch already. This chapter and last chapter is this angle here, where the sides of the angle are radii themselves, and the vertex is the center. So we have arcs then that are formed. All right. So one thing I can point out here is from B to C on the outside. That's called an arc, and arcs are just a part of the circumference of the circle. So we're going to get two ways to figure out the length, or to figure out the quantity of these arcs. One of them is called length, and one of them is called measure. So one of them is in degrees, and one of them is in units. All right, so an arc, like I said, is part of a circle. So one type of arc is called a semicircle, which is exactly half of the circle. So a semicircle is going to be something that looks a little bit like this. All right, it's exactly half of it. So ACB, you use three letters to name anything that's a semicircle or a major arc, is exactly half of however long the circumference is. A minor arc is anything smaller. So if you want to look at a minor arc, we could look at BC again, or CB. It's less than the length of a semicircle. Major arcs are going to be anything larger. So we could look at something like all the way through to this, C all the way through to D. You name a minor arc by the endpoints, and a major arc, or a semicircle, by endpoints and something along the way. So basically, here's what I would say. A minor arc, you only need two letters. Okay, but a major arc or a semicircle, you would need three letters. All right? Just because if you name one of those with only two letters, there's some major arc that could also be mistaken for a minor arc if you only use two letters to describe it. All right. So just an example of each. A minor arc is one that I had already highlighted in green, BC or CB. And the way we write it is we put a little arc hat just right on the top of the letters. A major arc I had highlighted in blue, it looks like. So I could either call it CAB, I need three letters to name that, or I could go BAC, all right? But the point is, C and B are the endpoints, A is somewhere in the middle, so A has to be in the middle of those three. All right? So we'll practice naming a little bit more. It says, what are the minor arcs of circle O? So here's circle O at the right. There's going to be really four minor arcs. You can name this one either AC or CA. All right. Then we have either AD or DA. We have DE, which is also known as ED, and then EC or CE. All right. Those are the ones that would be called minor arcs. They're less than the amount of a semicircle. Semicircles, all right, as for which ones are the semicircles. So there's one right here, ACE, okay, or ECA. There's one right here, EDA, or ADE, okay. Then there's actually two more this time. There's one here, DAC. And then lastly, either DEC or CED. Okay, so with semicircles, since there's two diameters drawn in, there's actually two different ones that I could, or four different semicircles I could name. Major arcs that contain point A. All right, major arcs again are more than a semicircle, so they're more than 180 degrees. So I could just start, for an example, there's going to be a lot of them that contain point A in this picture. I'm just going to name one and then I'm going to move on. All right, I could go A, and then to this point, this is a semicircle. So I could keep going through to the next point I see. All right, so I have four letters there. I only need three of them. A and D have to be in there because they are the endpoints. So I could say ACD or AED, or I could reverse the letters. So there's going to be a lot of ways I can name it. Maybe I will do one more. There's going to be a bunch of different ones that would work. Maybe I'll start at E and go all the way through here to C. All right, so then I could say that one would be E, and then I could either put D or A. I'm going to put A since that's part of the question here, and then C. So you name it with the endpoints. All right, I'm just going to write etc. to be continued. There's some more that I definitely didn't name, plus the idea of all of the ones that we could rearrange the letters and get the same idea. Okay, so those are just a couple major arcs that include A or contain A. All right, so that's how arcs work. So like I said, two ways to measure or quantify an arc. The first one is going to be called arc measure. And this is going to be something that is in degrees. So we could ask how many degrees is an arc. So a few things to know about that. The measure of a minor arc is equal to the measure of its central angle. So if this central angle is 50, I know that this arc is 50 automatically. Okay? The measure of a major arc is the measure of the related minor arc subtracted from 360. So if I wanted TQR, this would be 360 minus 50, since I just figured out that other one is 50, which is going to be where that 310 comes from. Because I know those two arcs have to add to 360, they make the whole circle together. All right? The measure of a semicircle is always just going to be 180. So that one, nothing too crazy to worry about. If I had something like this, all right, and I had this is maybe X and Y, all right, then this would be 180 degrees. Okay? We have to make sure that it goes through the center, though, otherwise we have something a little bit different, which we'll talk about later. Okay, so adjacent arcs. Okay, adjacent arcs are of the same circle, or arcs of the same circle that have one point in common, so they don't have any overlap. What happens with adjacent arcs is you can add the measures of them up to figure out the measure, how many degrees they are as one arc combined. So here's what I mean. If I knew that AB was 30 degrees, and then I knew that BC was 70, okay? Since they only have one point in common, one ends where the next one begins, what I can do to get the measure of the entire arc ABC, all right, I would be able to add up these two arcs, my 30 and my 70, and get that it's a 100-degree arc. So that's called arc addition. It's going to remind you of segment addition from first semester. It's going to remind you of angle addition, all right? We had area addition, all these postulates saying you can add up stuff as long as they don't overlap. All right, so this might be a good one for us to focus on for a little while here. Again, these are all just arcs. They want to know the measure, so they want to know how many degrees is each one of these arcs in the picture. So the reason it says arc here in words is because it's difficult to type in that little arc above the BC. But you can just imagine that that's what it should say. BC is going to be on the picture right here. That's a minor arc, so I know I should have an answer smaller than 180. If this central angle is 32, that means that this arc is 32. So there's not a lot of work to do for arc BC. Arc BD, let's look at that one. BD goes all the way through here. So I have a 32 and a 58 that need to get added up. So BD is 32 plus 58, which is going to give us 90 degrees. So that's exactly 1/4 of the circle. Okay, let's look at ABC. Arc ABC is starting here at A, going through, ending at C. If you notice, A and C go right through the center, which is O. That means that this is called a semicircle, which automatically means we have 180 degrees right there. All right, semicircle. All semicircles have 180 degrees. All right. So then let's go and look at arc AB. Arc AB, we'll do in blue here. A to B is this chunk here. All right. I know that A through C gave us 180. So if I take 180 and subtract one I already figured out, which is this 32 here, this piece would be all of that 180 except for those 32 degrees. So that would give me 148. All right, and then lastly, with arc AD, let's look here. Similarly, I would have 180 degrees all the way through. So if I have 180 degrees on this right-hand side, but I don't want this 58 of it to be included, then I could just subtract those two numbers. 180 minus 58 would give me 122 degrees. So that's how you work with measures of arcs. So the thing we'll talk about next is, what about the length of an arc? So length and measure might sound similar, but we need to talk about what the length of an arc would be, which is related to circumference, so an old idea. So let's take a look at what that is and see how much we can remember.